I think this is take 3 now. I think we're hopefully live now. And cool. There. I think this is working. So this is take 3 now on this live masterclass for today. I've been having some streaming difficulties, and actually I went through a full hour stream and it did not record anything. So we're starting over now. I believe this is actually live. So today's live stream is going to be covering stacking software, and this is the first in a series of master classes that we'll be having over the next few weeks, covering different approaches for this. So today we're going to cover the approach that I use for basically every Milky Way image that I stack. So some prerequisites for this image: you have to go out with probably a star tracker or shoot a whole bunch of really short exposures, and then you can take these images and blend them into a single image to reduce the noise in your image and increase the resolution. It just helps all of the details of your image just turn out better. So we start this out in Pixinsight. So Pixinsight is a professional astrophotography editing software, and it has like a whole ton of features. We'll walk through some of those as we go through this process, but you can fully edit your images here. I find it's better to do part of my initial integration and like some simple edits here, and then I move into Photoshop and run the rest of my edits over there. So we can start out by talking about the integration process. So I should probably mention that this is a pretty advanced tutorial if you're just getting started. I have other tutorials that cover much more simple processes that would be appropriate for you to learn some details in editing in Lightroom. And there will be more simple stacking integration processes that I cover in the upcoming weeks. So to do the integration here, we use this tool called weighted batch preprocessing in Pixinsight, which covers a whole bunch of different steps for merging images that you capture. So we have the different tabs here for the different types of images that you can integrate in this tool. So the first one is the most important one is the light frame. So this is the actual image of the Milky Way or whatever you're capturing in the sky. Those images that came out of your camera, they go into this light. Then we have a bias frame and dark frame. So these are two different ways to help with problems that your image sensor in your camera might have. And so the bias frames are calculated at are captured at the shutter speed of your camera. And you should try to keep a lot of the temperature and stuff the same for the biases and the darks. For flats, you don't have to worry about it the temperature as much, but the flats, it's important to keep the focus and other details close to what you were shooting when you capture the calibration frames here. So for biases, you get the shortest shutter speed, should be captured along with the light frames optimally. And then the dark frames are similar to the bias frames. Actually, I should be clear that these are both captured with your lens cap on. So you're trying to remove all light from the image and only capture any hotspots on your sensor, basically, that could cause problems in your final image. Maybe there's a hot pixel that looks like an extra star that doesn't actually exist. So by shooting biases and darks, you can remove these type of problems from your image. And so the darks are like longer exposures than the bias, so the exposure should match the light exposure here, and so these also should be taken in the same temperature as the light frame. So optimally, you take your light frames and you shoot your biases and your darks, and then flat frames are good for solving a few different types of problems. So a couple of the main ones are the vignetting of your lens. You can do corrections for that. And then it can also help with any dust or other optical problems that you might have on your sensor, on your lens, things like that. So if you want to try to improve your images, you can try to capture these. For most of my Milky Way images, the calibration frames are I found them to be not completely necessary. As we go through the editing process here, you'll see where flat frames could have helped my image, especially in this data set that we're working through today. But we'll see also that there's different software out there that can help correct that. So maybe you can save yourself a little bit of time capturing the flat frames and the darks and the biases. So the first step you would have to do here is add your images. So if you had calibration frames, you would add those. And then for light frames, you would add those. So you find them wherever they're stored. So mine, for this example, are stored here. So let's select like 10 of these. We're just doing this for example. I already processed it so that we don't have to wait, because this process can take a long time. I think it took an hour and a half, I think, to process 150 files that I put in for this specific example. So this is an example where I added 12 of those frames here. You can see they get added here. You can see the exposure time. And you can see if we go to calibration here, you can see what will be produced. It's going to take the 12 frames. It's going to create one new image in the end state. And then if there were other calibration steps here, each of those, there would be frames here. And then there would also be resulting master like images that you would create. So most of the settings over here are not super relevant. Like, I'm not going to go into detail on the weighted batch preprocessing. There's a lot of things here that we could talk about, but the one thing that's important is this CFA images. So that has to do with the Bayer pattern of your images. So I'm assuming if you're shooting the Milky Way with a wide field of view, you're probably not using a monochrome camera. So that means you're going to have color, and those colors are going to be red, green, and blue. And those things are captured using a Bayer filter. The Bayer filter is over the top of your camera sensor, and it allows your image just to show up in color. And so each camera has its own pattern, Bayer pattern. And so you can choose one here, or you can just select auto. And then you can choose different debayering methods. The default one has always worked for me. So that's the settings here. The rest of it is not very relevant. There's a cosmetic correction. So if it sees there's anything that's wrong in the image, it thinks it's wrong, it might make a little bit of a correction. So in my experience, I've had some cosmetic problems in some of my images. This hasn't necessarily fixed those. Maybe if I played with these settings or I applied some manual cosmetic corrections, I could have fixed it. But I was always able to fix those type of problems in Photoshop. So there's post-calibration here. There's not a whole lot of interesting stuff going on here. You want to make sure you're debayering to combined RGB so that you get a color image result that you can edit. And if you want to enable the drizzle here, you can, this will upscale your image basically. So it'll increase the number of pixels by using one of these functions here to increase the resolution. So that might get you a better result. So I don't usually use that, but it could help in some cases. And so if you come to the pipeline here, once you've configured everything, it will show you the steps that will be taken for this process. So we have to select a location here. So this is just the output folder for the actual integration results. So there's a debayer folder, a registered folder, and then there's the master results and then some logs. So these will all get created in the folder that you choose. So I've already done this, so you can see what the output looks like here. And so let's just cancel that since it's already selected. Another thing you might be interested in is selecting a reference frame. So one of the steps that happens during the integration process of these images, it will align all of the images based on the stars in the individual image. And so those will all get stacked based on the bright points, the stars in the image, and then it will blend them together using the integration algorithm that you choose over here. So it's selected window array sigma clipping. So it's basically a statistical model that does an analysis of the aligned pixels across all of the images that you input here. And then it will get rid of any images, any pixels that like are outside of the window. And so you can see that the actual final combination is going to be a mean after the clipping has completed. And so all the best algorithm is you almost always for any type of like Milky Way merging, it would be an average, because you'll get the cleanest, smoothest resulting image. So yeah, so then once you've made sure that all of your details here are selected, you've got your images here, you've got your CFA images selected here, and then you can go back here and hit run. So if you click run, it will go through the full process of all of the integration steps for these images, and then it will generate the results in this folder that you selected here. So since I already did that, we can just skip right to actually editing the photo. So if we open the File Explorer down here, you can see I've gone to the path where these files are stored, and I open this file right here, and you can see that we have an image. So not very interesting looking image. The image is what's called linear, and so it's not the light in the image is not stretched, so it's not very visible, but I can promise you there is definitely light in this image, and I will show you how we can show it. So if we want to temporarily show it, just for help us with the initial edits, we can go to the screen transfer function here. If I can find it here, right there, it's alphabetical order. So then you can hit this nuclear button here, and it will stretch your image. So you can see we have the Milky Way in the image here. So yeah, if you were curious, I think I might have mentioned it, but there's 150 images in this stack. And so you can see there's a lot of good detail here. But if you zoom all the way in here, you can see we have some problems because the stars are looking like they're bloated circles, which means my focus was not as good as it could have been. But thankfully, we have software to fix that in the process that I follow here. So we're going to leave the screen transfer function on open here. And one thing we could do is we could try to run a dynamic background extraction to try to remove some gradients here. But I think we're going to remove gradients in a different way for this edit. So let's go over to the histogram transform. So we're going to stretch the image so that the details we're seeing here are not like temporary, right? We want to make them permanently part of the image. So in order to do that, we're going to have to undo the changes we did screen transfer function. So you can undo the changes here, and then you probably want to apply it here because sometimes the undo doesn't always apply to the window here. And so we can close screen transfer function because we're done with that. And once we've got this histogram transform here, we want to create the visualization of it. So we want to make sure we're selecting the right image. And let's see, we want the 30-second one here. The other one, the images are from some other screen. So you can see the histogram here, the light in the image is all in the very dark end. And we're going to stretch it out so that it's in the visual range. So we want to make sure that this is selected, I think the same one. All right, we'll try to stretch it and see if it works, and we'll know if it's working or not. Oh yeah. So we want to stretch this all the way here. So probably take multiple iterations on this. So I guess maybe a quick note on these triangle, square, and circles in the Pixinsight UI if you're not familiar with it. So the circle is a real-time preview, so it brings up this window here where you can make changes without applying them and see what the changes would look like. The square button is apply, so that'll take the the changes here along with the selected image window, the top window here, and apply it there. And then the other way to apply a change is to take this triangle, which is like labeled new instance, and drag it onto a window and apply the change there. So for this tool, I like to use the square apply, and you can see that we'll take probably 2 or 3 iterations of stretching to get to a place where I like the image. So let's try to apply those changes. And you can see, like I was mentioning, we were going to be able to see some of the problems with this image. You can see the corners of the image are really dark here with vignetting. So that means that we definitely could have used some flat frames to try to correct for that. But other than that, it doesn't look like we had any dust on the image sensor or any other types of cosmetic problems that you might have to deal with in some images. Yeah, so basically we want to stretch this to the point where it looks reasonable, and we really don't want to clip the shadows or the highlights. We might even be able to stretch this a little bit further, but let's not do that because I want the corners to be exposed. That one's already looking kind of dark, so let's not drag the highlights down yet. So let's go with that. We'll say this image is stretched, so we have permanently made this image to be stretched in a nonlinear state. And let's do some color background neutralization here. I usually do these steps, may or may not be helpful depending on the image. So hopefully we'll be able to get rid of most of the greens with the background neutralization and the color calibration here. There are a lot of ways that you can make the colors, change the colors of your image. So these 2 tools are one of the ways. That result is pretty good. Obviously, the dark areas here are a concern, but I think we can probably correct a lot of that with Photoshop, some Photoshop plugin. All right, so now that we have this image here, it's looking more natural. It's still a little bit green. We could try to fix that here, but I think we'll try to fix that in Photoshop too. It might be more. We might get a better true color image. So we could use the SCNR to remove the greens, but we won't do that. So to try to fix some of these stars, right? So we were looking at the stars here that they're not looking super detailed, right? They're circles, so my focus was off. And then we can also see that some of the details, maybe the right terminology, they aren't as crisp as they could be. So we can fix a lot of these type of problems with a tool called Blur Exterminator. This is a Pixinsight plugin from a company called RC Astro. It does a really good job of fixing different problems in the image. As you'll see here, these stars will be pretty nicely cleaned up. They'll turn into points and light in the sky that look like stars after we wait for a second here. So like it's basically a really big change, right? Like we went from undo blur exterminator, these blobby circles, and then if we redo it, we end up with pinpoints like stars, like we expect to see. So that was a big improvement. And if we zoom out, we're gonna also notice improvements to the dark areas here. They're going to be looking like they have more details to them. And overall, we've improved the image. So the next step we want to go through is to remove the stars here. And so for removing stars, I always select the generate star image because I want to save the stars, and then do large overlap. And I'm going to take the triangle here, apply it to this image, and we'll get 2 resulting images, a starless image and one with just stars. And so that will allow us to make different set of edits on the starless image that can enhance the details of the Milky Way without affecting the stars, and then vice versa. If we want to make changes to the stars without affecting the detail of the Milky Way, we can also do that. So you can see it did a really good job here. Again, this star exterminator was a tool from RC Astro. There's a few details here that look off. We can fix those in Photoshop. So if we zoom in here, we can see the Lagoon Nebula, Trifid Nebula, other nebulas here. And yeah, there's a little bit of a greenish hint there, but we're gonna fix that in Photoshop. So what we'll do is we will save these photos. And so hopefully we will get the save dialog, which seems to have come up on a different window or something. All right, the stream is really having problems today. Let's see what this part worked perfectly fine the last time I did this. All right, it does not want to save, so let's do save as. Oh, there we go. This is working. So we'll save to this directory here. We'll call this one Starless 2 because this is the second version. And we do not want to save it XISF. We want to save it as a TIFF file. And then we will click save. And we need to make sure, this is a very important step, or you'll have weird issues in Photoshop. You need to make sure that you select 16-bit unsigned integer here, because Photoshop can't read the 32 or 64-bit encoding, even though that stores more detail. So we'll save that. And then we'll follow the same process for the stars. And we'll save it in the same location. We're going to call this stars, and we're going to call it stars 2 here. If we can, like this, save. We want to make sure TIFF is selected, so I think we're good there. And 16-bit unsigned integer. Okay. Cool. All right, so now we're gonna flip over to Photoshop, and you can see in Photoshop we already have an edited image because I already created an image of this. So the goal is to do better than my previous edit so that we can get a good result. So we'll open the two images we just saved, Starless 2 and Stars 2. And then the first thing I want to do to both of these images is run another plugin here from the company RC Astro called Gradient Exterminator, and that has the feature to allow you to it should fix the vignetting as well as remove like the it should also fix some of the color balance here, right? So the green hint should go away, so we should see a pretty flat color, and we can like verify that with the histogram on the left side of the image here. You can see that it looks like the blue and the green and red are really not, they're really not aligned very well. So this will automatically solve that for us. So again, there are tools in Photoshop where you could make these kind of fixes. Also, there are tools in Pixinsight for that. But the Gradient Exterminator does a really good job. It did a really good job with this image especially. So you can see that did not completely fix the vignetting problems, but I think when we add the stars back, that's going to be less of a problem. And yeah, so let's fix a couple other details here. So I noticed that there's a few stars that were so badly off that Star Exterminator couldn't actually detect them as stars. So I think we kind of want to do something about those. So one thing we could do is we could go look and see, because we could just remove them. We might actually remove a real star from the sky, so to speak. So there's a few ways we can do that. We can copy the layer here, put it over, paste it over here, and then if we screen the two layers together, we can see that if we turn off the layer, yeah, so if we just remove that, we're removing a star from the image. So maybe we don't want to do that, but we might want to make it look more like a star. So we can try to select, we have to make sure we're selecting the layer. So we're back on the starless image. We're selecting the layer, and then we can select this tool called the spot healing brush over here. This will allow us to do things that's not doing what I want it to. So if we click the over the top of it, right, it completely removes it. But I think we want to undo that because this is actually a bright star in the image. So we probably want to try something else. So we can try this tool. So the spot healing brush does not seem to be doing us any favors. So let's choose a different one. Let's actually do clone stamp. So since the background here looks pretty consistent, we can, and there's no stars in this image, we can just select by hitting the alternate key, and then selecting here. And you can see that as I do this, it's minimizing the star halo there. So it's also, we might want to do some of that because I bled into the star too much. So we're going to want to make our opacity less than 100%. So let's go with like 50%. And then we'll have this small brush tool here. And then we can just paint this until it looks like a star. Basically, that's the goal. And then for the other side, we're going to select hitting alternate and clicking. And then you can totally just paint this in here. And you can see this actually looks like a star now, as opposed to what it was before. I don't even know what that looked like. It looks like something flying away or something. So we got a star there. So optimally, we would remove this and put this in the star image so we can add all the stars together. But I don't think it'll be that noticeable. So let's check this one here. All right, so this one, it looks like the star actually got removed, but there was a star like halo that was added. So we're just going to use the spot remove tool to select, just remove it. So to increase and decrease the size of my brush here, I'm using the left square bracket and the right square bracket. So those will increase and decrease your brush tool. So let's continue to go through the image here and see if there's anything else that looks really badly off. So let's see. This one up here looks like it. So if we turn, yeah, it looks like we actually have the star in the other image, so we can remove that. Just remove it. Again, with the spot removal brush. We go through our image. There's a couple more over here. I am not exactly sure what that is, but we can try to, we can just remove it all together. See what it looks like. So we might have lost a brighter star there. It looks like potentially. But yeah, so it's up to you how much of this you want to do. If you want to leave these type of things in your image, right? Like you could also do the same thing I did for the other star that looked off. We can select the clone stamp tool and you just paint around here, right? And that'll allow you to reduce the size on this thing and at least get rid of the wings of it, if you will. And then it's probably actually a star there, so you'll be left with what look more like a star. So it'll look less unnatural in your final image. So we can test that by looking there. See, that does not look, that looks a lot better than what it was before. And so you can spend as much time as you want to fix these things again. So another bright star, we'll do the same thing here, where we try to do, clone snap, I don't like the way that worked. So if we paint this around here a little bit, not perfect, but it looks a lot better than it did. So yeah, we got those cleaned up a little bit. Like I said, optimally you would remove them from this image and put them in your star image, but I'm not going to go through that here. All right, so we're going to get rid of this star layer here because I will do some edits on that before we do the integration. So now that we have this image, we've applied the gradient tool to fix some of the vignetting in the corners and to also color balance things. Now we can go to the camera raw filter to make changes here. So one thing to note is you really might want to make a duplicate copy of this, right? At some point, if you make some changes and you can't undo it, you can always revert back to the initial version and do some edits there. So now basically that things are color balanced. We probably don't have to worry all that much about making changes to the color balance, so we can check that by doing this. Obviously, whenever you maximize your saturation or your vibrance and saturation both, then you're going to get some weird looking outputs. So this doesn't look too bad. We might want to adjust the tint just a tad. Yeah, like this. You can play with this, right? This is obviously editing to your visual appeal. You want results that you like, so you can do a variety of changes here. I like to play with I don't think I like the way the texture edits this one, right? It might make the details look more interesting depending on your personal preference. Let's see if we like the way it changes look. It looks like it's almost adding noise. Usually that's from the texture changes, so either tune those back or remove them all together. Yeah, that's looking a lot cleaner. We might want to increase the clarity a little bit. So these are just different ways to add contrasts, different types of contrast to your image. I have other videos on my YouTube channel here that will explain how each of these different effects works. So if that's something you're interested in, you can go find those. If we're still not happy with the vignetting here, which we might be able to improve just a little bit. We don't want to go too far, or else we might be adding some light that doesn't exist to the photo. But I think a little bit of vignette correction here is good for this image. Like that. Let's do that. Again, but we're just trying to add contrast to the image. So you probably want to add a little bit of contrast here. And so there's a nice purple hue to the Lagoon Nebula here and Trifid Nebula there. Let's see, the whole image looks dark to me, so we might want to brighten that a little bit. And then maybe bring some of the highlights down a little bit. Maybe there. And I think it's looking a little bit green. Let's see if we reset the green, the tint there. Yeah, I'm not 100% sure if I'm happy with the color balance here. Let's see. We turn this a little bit purple. Be careful we don't turn the white area here purple, because we want to make sure that things are balanced, especially in the bright area. The bright areas should be really close to white. Here, they're slightly reddish. This is again a personal preference thing. If you like the way the colors are balanced, then and the way it looks, then you can be happy with it. let's see, if we do that, if we reduce that, let's see what we got here. All right, if we just flatline it. So see, we got a little bit of a green in the background. So we can either change the tint, or we can try to increase the blue or decrease the blue, increase the yellow, right? Because yellow and blue make green. So if we subtract some blue, we'll get something more yellow. If we subtract some yellow, we'll get more blue. So it'll be less green in either case. But again, we really don't want to go too far with either one, or else we end up with a blue image, or we end up with a yellow image, which is also not desirable. So we want to make smaller changes here, right? So I think that's looking better. And we can check by hovering over the image, and then up in the right corner here, it will show you the actual values for the red, green, and the blue. And if those are looking close to each other and one is not completely dominating the others, then you've got a better, well balanced image. You can also check the dark point here, which is actually not very dark. So we definitely want to add more contrast to this image. So we can do that through a few ways. One way would be the curve here. All right, so if we do this, we don't want to compromise our highlights there. So we can reduce this here. Again, that's showing our vignetting a little bit more, but I think when we add the stars back, it'll look fine because there's a lot of stars in this area of the sky. So again, the flat frames could have helped with that type of detail there. Another thing you might want to do is increase or do some noise reduction. I don't think we're going to see a huge bump in this image, but it might clean up some of the details if you really zoom into the image, which probably no one will do. All right, so this still has a bit of a greenish hue here, so we might want to play with the colors some more, but we might do that in the Photoshop adjustments, because those allow some pretty fine-tuned color edits. So let's go with that, and let's see. Let's do a color adjustment just so I can show you how that works. And we might want to do a levels adjustment on this as well. So let's do the levels adjustment first. So we want the dark points in the image to be darker. So sometimes it's a good idea to clip the dark points a little bit. And you can play with this, right? Again, you want the final image to be visually appealing to you. So your goal is to find some level of contrast that you like. So looks like we still have all the details here. All the details are still visible here. Nothing is clipped. The very corner of the image, let's see. If you look down here to the RGB values, you can see that these are not 0, which means those are not completely clipped. So it should blend nicely with the star image. The same over here. Cool. So we were going to do a color edit because I'm still not happy with the color balance in this image. Let's see if we touch the color balance down just a little bit. I think maybe, what if we do, based on my experience, if we do a little bit in the midtones, a little bit on the highlights, and then maybe a little bit in the shadows, like that, we might get a nicer image. So again, this is personal preference, right? The greens are gone now, which I like. This part is a little bit purplish, so we could try to fix that by selecting the color balance layer here. And we have a mask. We can create a brush here. We can select black because we want to mask out some of it, right? We can have opacity really low, increase the size of our mask using the open, the closed square bracket. And then if we think this is too purple, we can with that part, with the middle there, we want that to be purple because the nebula is actually purple. But if we think this part of the galaxy looks too purple, or this part up here, we can just paint in a black mask over here at lighter opacity, and it'll bring back the color of the original image, right? So you can see here, let's see if we can see, we can turn it on and off. It's a very subtle change, but it softens the purples in this part of the image just a little bit, which I think helps the image a little bit. All right, cool. So I think the color balance is pretty good. The stretch on this is pretty good. And so let's go edit the stars. So we hop over to the star image now. We'll start by applying the gradient exterminator here to balance the colors. We'll probably get better colored stars. So you can see some of the stars here, they don't look fully bright, and that would be because when we removed them from the galaxy over here, some of the light stayed with the galaxy. So when you add the two images together, you would get the stars plus the galaxy, and it would look good. So we want to do a few things here. We definitely want to add some saturation and vibrance here to the stars. Again, this is again a personal preference thing. If you like the colors, if you don't like the colors, you might have to. So like these look really, those colors look nice on those stars. Some of the star colors might get messed up by the fact that they're in the Milky Way, like cloud of stars, if you will, and it's harder to bring out the right colors and details on them. But in general, with my Milky Way images, I'm generally not super fussy with the stars. We'll saturate them a little bit, and then we'll add some stretch. So using the curves here, we can make the bright points, the pinpoints of the stars brighter, and we can also probably drag the dark point out. This will remove some of the stars and make them smaller. It'll also remove some of the light from the background of this image, so that when we do the integration with the other image, we screen the two images together, we're not gaining more light from this image because we want the Milky Way to be the primary light, and then from this image we want the stars to show up. So by brightening the bright point of the stars here, then we can bring out the star details without bringing in extra background light and noise. So, all right, we've got these layers. We can merge all these layers into one. We'll call this stars, and then we can hit Command C or Control C if we're on Mac or Windows. Paste the stars over here. Command V, and that is not pasting for some reason. All right, there we go. And now that we've got our star layer here, we can do a screen blend here. And let's see here. Let's look at the image. So immediately I'm seeing the vignetting and the corners here. And the stars are lightly added here. You see the pinpoint bright stars are showing through, and the lighter the stars are not shown, which is generally considered a more desirable look. You can see we got some nice color on these nebulas in the middle of the Milky Way here. And let's rotate the image. Do 90 degrees clockwise. Northern hemisphere, that's the general orientation for the Milky Way during the later summer. So this image looks pretty good. I think I want to quickly see if we can fix some of the vignetting there. So I'm going to keep everything as is here, merge these layers all together. If I'm going too quickly and you have questions, feel free to add those in the chat and I can try to answer them. And yeah, I'll probably do other videos like this so we can walk through the different steps. So let me let's do the camera raw filter and see if we can fix some of the vignetting issues. So under effects, we'll see if we can brighten the corners of the image just a little bit. So it's not like the first thing you see when you look at the image. Maybe other people wouldn't look at that as the first thing, but when I look at the image, the first thing I see is the vignetting in the corners of the image. And that's not natural. That's an optical artifact from my lens, not capturing light evenly throughout the image. So looks like this effect does a pretty good job. There's still some darkish points there, but I think at this point it's not the first thing I see in the image, and some level of vignetting actually helps focus your attention on the center of the image. So yeah, so this is looking pretty good here. Let's see if there's anything else that I want to adjust. So another thing you want to watch out for is the edges of the image. So I didn't crop my images at all. So in Pixinsight, you might want to run the dynamic crop tool to fix problems like this. You can see here when I merged my images, there must have been some misalignment. So the edge of this edge here does not look very clean. If you go through the image, you might find, oh, this edge over here does not look clean either. So you definitely want to make sure that you're cropping out problems like that from your image before you say you have a final image. So I'm pretty happy with how this looks now. We're going to say this is done. We're going to go over to the crop tool here, and we'll let's see here. Let's select, I think this image should still be in the 2:3 ratio. So we saw the top and the left side were the sides that were off a little bit. So we will see if we can select a crop here that cuts off all the bad parts without taking away too much of the detail. So I think that looks close enough. And then if you want, you can delete crop pixels, but then keep in mind they're gone. You can't really get them back. So I'll just click done. Now we have the cropped 2:3 format image. Now that image is completed, we will, let's see, go through here. Make sure all the edges are clean, which I think they are. And then, I guess since we have a minute here, I was intending to go for an hour, we can go through my process for like posting to Instagram, so I can show you the details of what I do. So first I would export my image here. Obviously this is not the Instagram format. The size of the image is a little bit bigger than what I usually upload for social media. It takes too long to upload, plus a lot of sites won't accept or have trouble accepting 6 megabyte files. So I'll export this. I'll put this in my folder. So this was taken at a place called Mullis Lake. So let's see, we are in Colorado, 2024, and Mullis Lake. So we will call this one Milky Way 55 millimeters, because that's the lens I use for this. We'll save that, and then we can close the star image here because we don't need that anymore. And then you might want to save this image like the TIFF file. So you can hit save this. And then let's see, did I accomplish my goal of getting better than the previous image? Yes, this is, in my opinion, definitely a better result. So yeah, the second edit definitely worked better. All right, so then we'll go back. We want to open the image that we just saved. so that we can crop it for and save the file size properly for Instagram. And then I don't usually worry about the file sizes for other social medias. I just take the Instagram format and post it across all Facebook, Twitter, Threads, whatever else. I just post the same thing, so that I don't have to think about cropping and having different images. So this was taken at the Mullis Lake. So there's the image we just saved. So I open this one, and then one of the reasons I do this is I don't want to lose my reference image. So if I open the JPEG version, then I'm not accidentally making changes or something to that image that I wouldn't want to make. So I want to change to the 4:5 format ratio because that's what will work well on Instagram. And then we can crop to wherever we want. So let's see, I think I'm going to try to get rid of more of the vignetting on the bottom here with this crop. So I don't want to remove this dust cloud here though, because that's kind of cool. And we can put the Lagoon Nebula here at the bottom third of the image, which will work well for a composition. So I think something like this will include the best details for this image. All right, so we'll click done here. Then we'll make sure we like the way this looks. I think this is looking pretty good. And then I'll do an export here. And for this social media, my goal is to make the short side the width or the height, which for Instagram is basically always the width. You want to be 2,000 pixels about, give or take a little bit. So I usually select, so 33% would be less, 25% is way less. So if we do 50%, we get 2300, so close enough to 2,000 for me. You end up with 1.9 megabyte file size, which basically works for any social media platform. And then you export this to a different directory. And so I have, for each of my locations where I shoot, I have a directory where I store my social media images. And I'll just save that there. And then I have a image that I'm ready to post to social media. So yeah, this is the process that I follow for editing my photos. So the merging and stacking that happens in Pixinsight, the initial edits there, and then the integration, the final edits and other integration of the stars in the Milky Way in Photoshop itself. And so as you can see, I really like the tools from RC Astro, the star exterminator, the blur exterminator, and the gradient remover one tool. Those three are the main ones that I would use. So how I use them here. And I highly recommend those if you're going to be using the Pixinsight software in Photoshop for your editing your Milky Way stacks. So like I mentioned at the beginning of the video, this is a complex process that I follow today. There are more simple ways to do this, and I will be having future videos where I cover that process. So I guess we can wrap up the video now.